Hello, today you're going to learn how to simplify radicals, which you might be thinking is more of an algebra topic, but it is extremely important for geometry, in particular Pythagorean theorem. So a radical is just another word for square root. So let's just review what a square root means. So square root means what number. Now, technically, this means what positive number, when multiplied by itself, will equal the number under the radical, called the radicand. So square root of 25 equals 5, because 5 times 5 is 25. Square root of 36 is 6, because 6 times 6 is 36. And yes, negative 6 times negative 6 is 36, but this symbol is only asking for the positive square root. The negative square root would have a negative outside. So square root of 100 equals 10, and then square root of 2500 is 50. Now we look at the square root of 50, and you would have to use the calculator, but we can estimate. We know 7 squared is 49, and 8 squared is 64. So we know it's going to be a little over 7. Now you can type this in the calculator, and to 2 decimal places it's 7.07, but it keeps going. And you'll notice there's no repetition in the digits. That's because this is an irrational number. So irrational numbers cannot be represented as fractions. Therefore, the calculator can never give you an exact value. So this is an approximation. Isn't this kind of like the last unit when we used pi? And so once you type the pi button on the calculator, you now have an estimation, or an approximation, and it's not an exact value. So we actually, if I ever say to write the exact value, it is in radical form, and that's the reason we're simplifying radicals today. So square root of 2 is also irrational, and that would be approximately 1.414, and then, again, irrational. All radicals are irrational unless they evaluate to an integer. Okay? So next. So it's helpful to know perfect squares when we're simplifying radicals, and you'll see why in a minute, but let's just review some of our perfect squares. So we know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 times 4 is 16, 5 times 5 is 25, and then I'll finish writing the rest. So these are good to have handy or in the back of your mind. And you'll see why in just a minute. I forget 14 squared. 196. And 15 squared is 225. Okay? So let's look at how we actually simplify a square root. So a square root, as we said, evaluates to an irrational number. Now, when we write the exact value, we do write this as, you keep it in square root form. But a simplified version means we pull out any perfect squares. So 18, we know is going to be the square root of is going to be 9 times 2. So you can actually write the square root of 18 as the square root of 9 times the square root of 2. Okay? So when you multiply radicals, you can multiply the numbers under the radical. So now the square root of 9 is one of our perfect squares, so that's 3 times the square root of 2. And then you can check on your calculator by typing the square root of 18, which is 4.24 ... And then 3 times the square root of 2 should come out to the same thing, and it does. So that's a way to check when you're done, which is kind of nice. Okay, so the square root of 75. So you can go back to that table or the list of all the perfect squares, and basically you're thinking, what can I multiply, what factors of 75 are perfect squares? Well, 75 is 25 times 3. So you write that as the square root of 25 times the square root of 3, and then evaluate. Square root of 25 is 5, 5 times the square root of 3. And then you can check on the calculator if you like. So what's the purpose of this? Well, you'll see when you start doing some of these calculations in this unit, you might end up with square root of 18 as an answer, and then your friend might have 3 times the square root of 2. And it's a way, if I say, put it into simplest form, you'll have the same answer to check. Another way is, for example, 3 times the square root of 2 is literally saying that value is 3 times whatever the square root of 2 evaluates to. So it's a way to compare. So let's say one side of a triangle is the square root of 2, and another side of a triangle is 3 times the square root of 2. You're able to quickly see the ratio between the two. Okay? All right, square root of 80. So we need to think of some perfect square factors of the number 80. Okay? Well, one way to do this would be to say, well, 80 is 4 times 20. So square root of 4 times the square root of 20. Okay, so that's 2 times the square root of 20. But now look at what you have. Square root of 20 has a perfect square factor in it. So this is not simplest form yet. So the square root of 20, let's see, it's 2 times 10. Well, that's not a perfect square, but 4 times 5. So 2 times the square root of 4 times the square root of 5. So now you have 2 times, now the square root of 4 is 2 times the square root of 5. So that gives you 4 times the square root of 5. And again, you can check on the calculator to see the decimal approximation. Now, is there a way you could have done this in less steps? Yes, there is. And let me do that here. So we have, I need an eraser. So we have the square root of 80. Well, instead of taking out a 4, it turns out we could take out 16. So 80 is actually 16 times 5. Now, maybe you didn't know that, but something you could do is go through and check some of those higher perfect squares and use your calculator. So, like 80 divided by 25, 80 divided by 16. Oh, 16 is 16 times 5. So that's a way to do it, or you could just use the smaller ones and continue to simplify as you go, like I showed here. So square root of 16 is 4, so 4 times the square root of 5. So you can do either way. So 240. Let's see. So I'm going to do a little thought bubble over here to the side. Okay, so you have 24 times 10. That's not a perfect square. Let's see. We could do... How about we do 4 again? So 4 times 60. So you could use your calculator to think about this. So 240 equals, all right, so square root of 4 times the square root of 60 is 2 times the square root of 60. Okay, well, let's see, does the 60 go any further? 6 times 10, nah, that's not going to work. 4 times 15, that one's going to work because 4 is a perfect square. So 2 times the square root of 4 times the square root of 15 is 2 times 2 times the square root of 15. It's good to write each step out like I'm doing, and this will give you 4 times the square root of 15, and 15 would only break up into a 5 times 3. That doesn't help us. So 4 times the square root of 15. I'm actually going to show you another method in tomorrow's video that you may like using factor trees. I'm using this one because DeltaMath will have you use this method for this assignment. So we have 2 more. So square root of 600. How about I have you try these? So go ahead and pause the video and then give them a try. And here you go. So the way I did square root of 600 is I recognize that's 100 times 6. 100 is a perfect square. So square root of 100 is 10 times the square root of 6. Square root of 6 does not have any perfect square factors, so you're done. So now the square root of 180 is the square root of 4 times the square root of 45. That's just what I started with. But you could have broken this up into 36 times 5. So square root of 4 is 2, square root of 45, and then I recognized 45 is not simplest. So I broke that into a 9 times 5. So square root of 9 is 3, and then you have the square root of 5, multiply the integers, 6 times the square root of 5. And there might be other ways, orders that you might have recognized the 9 first. So it would be 9 times 20, and then 20 is not simplest form because 20 is 4 times 5. So there's different orders that will lead you to this simplest form. So as always, if you have questions, email or come to the review session at 1:30. Have a great day.